Okay, so we continue to study this example 2. Yeah, and yesterday we finished subscription D. So now we go to subscription E. Okay, so go back. So the question is, if the generator slot were suddenly disconnected from the line, yeah, so what would happen to the terminal voltage? Okay, yeah, normally the generator connects to the lot, okay, but some reasons we suddenly disconnect the lot. Okay, so we have the formulas, right? We considering Lagrange lot, right? Lagrange lot. So that means we have V phase EA minus J XS. Minus what? Minus RA plus JX times IA, right? Right. So we disconnect the lot. That means now IA becomes 0. Okay. So we are so we have V phase is EA, right? Okay. So if we consider magnitude, you get how many? V phase how many? And V phase we get the values here, right? V phase is AI is how many? 5, 3, 2, 1. Okay, 1. I mean the magnitude. Okay, yeah. So we have the answer. So if we disconnect the lot, the internal phase voltage equal to the terminal voltage. I mean the terminal phase voltage, and we get 5.2 volt. Okay, because IA is 0. Next, question F. Now we have the lot. Okay, suppose that the generator is connected to the lot, drawing 1,200 amperes at 0.8 power factor leading. You know, at the beginning, the lot is 1,200 amperes and 0.8 power factor lagging. Now this is leading. Okay, this is leading. So we have IA, right? This is remember this is 3 phase, so this is line current, right? And then we have delta connection. So phase current equal to line current equal to, right? Oh, sorry, divided by what? Divided by 0.3 because delta connection, right? Delta connection, so phase, I mean I phase. So phase current equal to line current divided by 0.3, so you get 1,200 divided by 0.3. How many, please? I remember 639, right? 693, right? Double check. Okay, good. So we have the formula, right? So V phase, and then we have power factor leading. Okay, and we have 0.8, so we calculate. So cosine phi A, cosine theta. Cosine theta is 0.85, 80, right? So we can get theta how many? I remember the 37 degree, right? Yeah. So remember that this is leading. So if we indicate complex number IA, this is what? 693 with plus or minus 37, plus 37, right? Because this is leading. Yeah. Yes. So now we can calculate V phase, right? V phase. Oh, and then no. And how much field current would be required to keep VT is at 480 volt. And we know VT is A. No, we know this is 3-phase, so VT is line voltage. Okay, and then because we have delta connection, so V line is V phase is VT is 480 volt. Okay, 480 volt. Yeah. And yeah, we know we face a magnitude of we face 480 volt with 0 degree. With 0 degree. And we have IA, right? This is number 1, this is number 2. So we can get, we can calculate EA, right? So EA now is V phase plus 1 plus RA plus JXS IA, right? Why? Because they ask us to determine field current, okay? So if we would like to determine field current, we need what? We need open circuit terminal voltage. If we know open circuit terminal voltage, you can get field current. And open circuit terminal voltage means EA. But this is, remember, this is line voltage. This is phase voltage. So when we calculate EA, you need to determine the line voltage, okay? Open circuit line voltage. So remember, this is phase, right? Phase. So you get how many? V phase A 480 with 0 degree plus RA. I don't know. I forget. I how many? RA how many? 0.015. Oh, why we have 1 here? Oh my God. Okay. Plus what? Plus J 0.1. That's correct. XS. XS how many? 0.01. Oh, yes, here. Okay. So times 1. Just multiply by IA, and IA is 693 with 37. 37. Of course, this is plus. Now, please, how many? Come on. And we know because this is leading, right? So this, so we have the observational equation. EI must be less than V phase, right? We have the comparisons before, okay, or equal to V phase. Yeah, now, double check. Now we have V phase is 480 volt. 480 volt. So we have EI is less than V phase. Okay. And yeah, come on, please. 400 what? 50.82 phase angle? 7.8 degree. 7.8 degree. Okay, now check. Yeah. You understand? Yeah. Yeah. And then we satisfy the theory. Yeah, theory. So now we have, and remember we have delta connection. So EA equal to what? Equal to E line, right? E line, right? Equal to 450.8 or nearly 451 volt. And then we use what? We use the arch. You can get IF, right? You can get IF. And IF how many? IF how many? 450, right? 450. So we hope we get the IF is maybe 4.1 or 4.0 amperes, right? Right? Yeah. Yeah. How many? Oh, 4.1 amperes. we have the observation. So if we have leading, we only need IF to be 4.1 ampere. You can get V phase is 480 volt. But if we have lagging, we need more IF. More IF. So if we have lagging, IF is look 5.7 amperes. Okay? Yeah. And we can indicate the phasor diagram, right? So here we have V, this is x-axis, right? So here we have V phase, yeah, and IA is less than V phase 37 degrees. So here maybe somewhere it is 37 degrees. This is IA. Okay. So we have IA here, maybe here. Okay. IA, then this A, J is XS, IA. Do you agree with me? Why? Because IA is 0.015, so the segment is smaller. And XS is 0.1, so the segment is bigger than this one. Okay, so we can get what? We can get DA, and the phase angle here how many? 7.8 degree. Okay. So for the final exams, I would ask you to calculate delta. Okay, to calculate delta. It's easy. It's easy, right? Because this is theta. This is delta. Okay, so we can conclude that delta is 7.8 degree. Okay, yeah. We also calculate theta upon 37 degree. We also calculate Raman, right? Raman is what? Raman is the phase angle between EA and IA. Can you get how many? 44.8 degree. Okay. Yeah. Questions?
I'm a bit confused. Isn't the current of the aperture leading? If it's leading, should it turn counterclockwise upwards?
This one we can use 37. But 37, that means we stay here and then we move to II. But when we calculate, the different phase angle, we don't need to consider plus or minus. Different phase angle between EA and II. Okay? If we say II is II with minus 37. Yeah, that means this one is. Oh, sorry. This one is what? Oh, sorry. Okay, my stupidness. Okay. So maybe here is lucky, right? Yeah. Sorry. My stupidness. Yeah. Then again, here for leading, right? Oh, my stupidness. So here is V phase. Yeah. Yeah, this one for lucky, right? So for leading, this one is IA. Yeah, I'm sorry. 37. Okay. So we can get this is IA, RA, and this one is J is XS. Maybe one smaller a little bit. This one is IA, and this one is, this one is JXS, IA. Okay, and this one is EA, right? EA. Yes. Okay, I'm sorry. Yeah. So here we have EA and we face. No, right? Because just 7 point. So maybe here no. We just reduce a little bit here and right here. Okay, J's. This is IA. This one is J's XSIA, right? Yeah, maybe very small. Okay. Yeah. So this one is how many? 7.8 degree. Okay. It's very small. Very small. So we have delta is 7.8. We have theta is 37. And now we have Raymer is how many? 37 minus 7.8, you get 30.8 degree. No? Here. This is Raymer. This is EA. You need to consider for the final exam, you need to make sure we have the ratio, ratio. That means we face 480. How many square? For example, here is 0. Here maybe 150. Here is 300. Here is 450. So here is we need to consider the ratio. You get more accuracies of the phase diagram. But okay, this one is okay. But you should make sure the magnitude of EA is less than the magnitude of this phase, right? This is 480. This is 450. So yeah, very difficult to recognize. This one is similar to this one. Okay. Yeah. Understand? Yeah. Thank you so much, my students.
It should be 29.2 rather than 30.8. 37 minus 7.8 shouldn't result in 30.8 degree.
Yes.
It should be 29.2.
Okay. Sorry. 29.2 doesn't. Yeah, that's also okay. Yeah, my mistake. 29.2 degree. Okay. Yeah. Any questions? So this one for lithium. This one for lithium. Yes. Okay. And this one for lucky. Any questions? So, question for you. Which type of lot, leading or lagging, needed or lagging to maintain the rated voltage? Of course, lagging, right? For lagging lot, we need IF how many? 7. Okay, so for leading, you only need power 1. Why? Because for leading, we supply more reactive power. Okay, so we reduce IF. Next question. Which type of lot, leading or lagging, places more on thermal stress on the generators? Leading. Okay. Yeah. And here we also get the answer come from ChatGPT. Yeah. The first questions and the second question. Okay. Why for this one? We get more thermal stress because V phase is constant. V phase is constant, right? Yeah. Yeah. So we reduce EA. Yeah, we reduce EA. That means you need more phase angle, right? Phase angle. This is constant. So when we reduce more EA, we need to increase. You need to increase the phase angle because the current loss is constant. So if we increase 37, that means we increase Q, right? Q. Look, we have B is going to be generated is 0.3 VL IL cosine theta. And for Q, reactive power, you get 0.3 VL IL sine theta. Okay? So if theta increase, that means cosine theta decrease, right? Yes? And sine theta increase, so sine theta increase, QR increase. QR is what? QR is non-useful power, and this one will generate more temperatures, more thermal stress. Do you understand? Yeah. So this is the reason. If we have a leading loss, you get more thermal stress on the generator and this protection here. Here. Do you understand? Yes, good. Yeah. Okay. Yeah, here, leading current haze, the magnetization effect that add to field flux. Okay, blah, blah, blah. Okay, so this is lacking condition, this is the leading condition. Okay, yeah. Now we go to the example 3. Summary. Look. Here they give us the objects of synchronous generators. I mean 3-phase synchronous generators, right? We have a Y connection, right? Y connection. Y connection means we have realized a square root of 3 V phase, right? Yes. we have the frequencies FSH is 50 Hz. We have 480 volts at no loss. At no loss, so that means no loss mean EA, and of course this one is line voltage. Because three phase, so the voltage is always line voltage. Okay. So we need to calculate phase voltage. So no loss, that means EA equal to what? Equal to V phase, no loss or open circuit, right? And this is phase, this is line, so you get 480 divided by square root of 3. This is Y connection, right? How many, please? Help me. 227.12 volt. Okay. What else? They give us the information of both phase synchronous reactance of 1.0. So that means SS is 1.0 of both phase. Both phase. How about RA? No RA. Okay. The armature resistance is being ignored. So that means RA is 0 ohm. What else? Its full load armature current is 60 amperes. And 0.8 power factor lacking. Full load condition. So if we consider full load condition, you get IA rated. Remember that. This one is Y. Three phase. So the current and the voltage are always line parameter. So this one is line current. And this is Y connection, so is equal to line current, right? I emphasize again. If we have three phase, the voltage is always line voltage. The current is always line current. Please remember that. Okay? This is the rule for every three-phase systems. Yes? So here you have the and now this is Y connection. So phase current is equal to line current equal to 60 amperes. We have 0.8 power lagging. That means we have IA is 60 with minus 37 amperes. Right? Yes. What else? This generator has friction and weakness losses of 1.5, core losses is 1.0. So that means delta B F and typical use is 1.5 kilowatt and core losses. Right? The core losses is the combination of hysteresis loss and eddy current loss. Remember that? Yeah. And you get 1.0 kilowatt. Hey. This is 60 or 50. It should be the same, It should be the same. Later on we check it. I think this one is 50, not 60. We cannot get the different frequency in the same questions. Okay. Later on we check this one. Yeah, the field current has been adjusted so that the terminal voltage is 480 volt at no loss. Now, no loss. And the no loss. Okay, and the no loss. So if we have no loss conditions, you get IF for no loss. How many? I don't know. Okay, the question also give alternative information. Right? So, that's question 8. Yeah. What is the speed of rotation of this generator? To calculate speed, we need the number of pole pairs. So pole pairs is 3. Pole pairs. Yes. So we get synchronous bit. Synchronous is 60 times FSA, right, divided by B. So 60 times, we just will check 50 or 60. Oh, 50, okay, yeah, so FSA is 50 divided by B. How many B? 3. You want the value of B is 3, so you get 1000 RPM here. Okay. So we also calculate omega m or omega sin because this is synchronous bit equal to 2 by n sin divided by 60. Get 2 by times 1000 divided by 60. How many? Yeah. 104.7 radian per second. Please double check. Is it correct? Oh, this is 76, right? 76 or 26? 76. Because here, you know, yeah, so nearly 2771. So we finish description A. Description A. Now description B. What is the terminal voltage of this generator if the following are true? They require to calculate terminal voltage. Okay, so we have terminal phase voltage or terminal line voltage. Okay, so we have the general formula. We have V phase is EA minus, right, minus I plus JXS times IA. Is that right? Yes. Yes. So here we have V phase, so we need to calculate V phase. So V phase is EA with the phase angle. My I is 0, so give us minus JXS IA. You know. Do we know SS? Yes. Do we know IA over dot? Yes. Do we know EA? Yes. But we don't know phase angle. Right? We don't know any information about phase angles of EA. How can we solve? Right? And I also introduced to you the method. We need to consider magnitude. Okay, we try to modify this one a little bit to become the real part and imaginary part, and then you can calculate the magnitude of the V phase. Do you remember? Okay, so now, yes. Now we modify a little bit. We have EA is what? A is V phase minus JXSIA. Do we know the phase angle of V phase? Normally is 0 or plus, right? Yeah. So here we have EA is V phase with 0 degree. Minus JXS IA we modify it a little bit, right? We modify a little bit. We can get how about minus, right? Minus theta. Because if here is V phase, here is IA and theta. Theta is what? 37 degrees. Right? Do you repeat me? Yes. Okay, continue. So we have EA over dot is we face a little bit the so we just ignore minus jxs. So IA with minus cosine theta, that means we have what? We have minus, we have cosine theta minus j sine theta. Do you agree with me? Cosine of minus theta is cosine theta. Sine of minus theta is minus sine theta. Okay, so here we face j and j squared is minus, and this is when you get minus xs sine theta minus j xs cosine theta. J squared is minus. So this one is real part. This one is imaginary part. Do you agree with me? So far, any questions? Something wrong? This is plus, right? This is plus, oh my god. Yeah, plus. So this one is j, right? J minus. J is minus is plus. This one is plus. Sorry. My student again. Okay. Something wrong? Sorry? Oh, I. This one is I. Yeah, I forgot I. Yeah, you are right. Yes. Okay? Yes. So, here we can get, so if we have EA absolute, that's the square root of 1. We face plus IA xs sine theta square, yeah, plus xs cosine theta IA, yeah, square. Okay, or you can get the reface, right? Reface is what? Is yeah. The square here, right? So we don't have this one. Are you with me? So we have what? We have EA square that's correct. This one like the quadratic equation. So you can use your calculator to get a reface. Or you can calculate reface, right? Reface. So reface is what? EA is what? Yeah. So reface is EA squared minus xs IA cosine theta square. Okay. And then need to modify this one, right? To get the quadratic equation. Okay, so yes, of course you can do it for yourself, okay? And basics, okay? That's okay. Yeah, maybe we just use the values. This will be better. So EA square how many? EA is 277, right? 277. Okay, so you get 277 square is we face plus how many please? IA is so we calculate this one, right? This one we can get IA how many? 60, right? Times XS how many? 1. How about sine theta? Sine theta, that means sine 37. Please help me how many? How many please? 36.1. 36.1 square, right? Plus we have SS cosine theta IA square. That means the 36.1, and we have 60 times 1 times cosine 37. How many please? How many would? 47.91. So here 47.9 square. Now use calculator to calculate V face. How many please? This is important. I don't know. You should use a calculator. Nó giống nhau vậy, thầy cũng thầy đây cùng xào qua cơm giống nhau nha. Qua thầy mới lấy về thì cũng giật thử một chiếu nguyên. Khó à. How many? 2. We have 2 value, right? 236, 37, and the other one. Khái niệm nữa chứ không nói. Sao có nghiệp được? Tào lao. Có 2 nghiệp chứ. Phương trình và 2 mà không đánh là trùng nhau hả? Okay. Oh, you just take this here, you know. So, or we can, yeah, anyway, it's very easy for you, right? And you get 237 volts. And now this is the answer. So you need to follow my explanation here, or if you remember the formula, that's okay. That's okay. So now, if this one is lucky, you get V phase is 237 volts. Yeah, even though we don't know the phase angle of AI, that's okay, but we also get the magnitude of phase voltage. And the question requires to calculate terminal voltage. That means line voltage. So we can get VT is what? Is square root of 3 times 237 because this is Y connection. How many bits? 410 volts. Yeah, finish. Finish for this case. Locking condition. Now we next one. We have 1.0 power factor. Oh my god. 1.0 power factor. That means theta is 0. Right? Theta is 0. Look, theta is 0. So, if theta is 0, I say this formula is here. Here, right? This is number 3. So, here we have V phase is EA minus 1. Chase XS IA with the phase angle 0 degree. Do you agree with me? Yes. So that means we can get EA minus chase XS IA and we just skip 0 degree. So you can get V phase square is EA square, right? Right? Plus XSIA square. Because this one is real part, this is no, wrong, right? Because here we don't have the phase angles. Okay, so yeah, we will need to modify it a little bit. Okay. Yeah, it's wrong. So we need to move for EA here. So that means we have EA is V phase with the phase angle 0. Yes, plus J's XS IA. Right? Yeah. So we can guess EA square is V phase squares. Yeah, for more clearly, right? Yeah, plus XSIA, yeah, squares. Okay, and then yeah, you can get V phase squares is EA how many? 277 square minus. Of course, you keep this one, that's okay. But for consistency, we follow minus 1. XS is 1, IA is 60. 1 times 60. Totally square, and you get how many, please? V phase. V phase. 270.4. Okay, yeah. And then you can get terminal voltage. So root of 3 times 2 is 70.4. How many? For 68, right? For 68. Any questions? Of course, if this one, we can get V phase square, yeah, and you know, if we consider this one some mistake. Why? Because this is complex, right? This is complex. Complex does mean we have EA with the phase angles minus J's XS IA, right? We don't have. So here that means EA both sides we don't have the phase angle plus J side we don't have the phase angle. Right? Right? Minus J's XS IA. Okay? We don't know the phase angle here. So to be careful. Okay, this one is not real part because this is complex. This is complex. So we have real part and imaginary part. So to be more clearly, we need to modify a little bit. AA move to the left side because we already know the phase angle of V phase. Okay? Any good? Now, continue. Continue for this condition, 0.8 power lead in. You have 5 minutes. So we have 0.8 power factor lagging. Oh, get in. Yes, yes. So now we have EA is V phase, right? Right? Plus what? Plus J's XN. And now we have IA with the phase angles. This is it. Right? So this one should be plus theta. Right? Plus theta. Do you agree with me? Yes. Yes. Okay. So here you can get V phase with 0 degree plus J's XS IA cosine theta plus J sine theta. Yeah. So that means here we have V phase between 0 plus J XS. This is J and J. So here you get minus what? Minus XS IA sine theta, right? It is real part. And then we plus J's XSIA cosine theta. It is imaginary part. Did you read me? Okay, so now we can get EA square is V phase minus here. How many? Minus 36.1 square. Plus what? This one square. How many? 47.9 square. Now you can get V phase. Please help me. How many? We hope we get 308.8. We hope. Because this lead in, lead in. This lead in show AA should be less than, right? V phase. And AA is here is 277. So we find how many? It's up to you. You need to calculate for yourself. How many? Come on, quickly here. Don't use mobile phone, use and calculators. Practice.
308.92.
92.
92.
Nearly 309. Yeah, that's incorrect, right? That's incorrect. Similar to the theory, right? So here you can get, we terminal this is sort of 3 times 309. Then you get 5, 3. Remember that the question required to calculate terminal voltage, not phase voltage. So when you get phase voltage, please remember to calculate terminal voltage. You have Y connection. Is it clear? Any questions? Questions? Thì cái chỗ này là để giải thích nó làm như thế nào. Thấy chưa? Khi mà thì mình dùng gốc bản chất này là gì? Là theta trừ theta đúng không? Thì theta thì khi mình chỉ mở ra mình là cos của trừ theta là cos theta nè. Còn sin của trừ theta là trừ sin theta. Tức là đến đây là còn dấu là biểu trừ này. Và khi xuống đây thì mất dấu để mình chỉ cái dấu này là cái hàm giá này. Thành cái hàm tiếp xúc là gì? Cos theta trừ sin theta thì không còn dấu. Nè, có bạn hỏi thầy là tại sao xuống đây nó mất mẹ biểu trừ rồi? Này là thì chỗ này thầy làm tắt thôi, đáng lẽ là mấy đứa phải biết từ cái môn mà nó kịp sớm kịp rồi, đúng không? Học lý hình chỗ này nè, chỗ này là biết rồi đúng không? Tức là bằng ai ấy cosine của trừ theta cộng với j của sin của trừ theta, đúng không? Thì cosine của trừ theta là cosine theta, sin của trừ theta là trừ sin theta, j thì ghi xuống, hiểu không? Thầy khỏi cần làm bước này nữa. Mấy đứa là sinh viên năm 3 rồi thì chùm rồi. Biết hết rồi, đúng không? Tên gì? Tên gì? Tên gì? Hả? Lễ hả? Lễ để có tóc đẹp quá không? Không cách. Có bò chưa Lễ? Hả? Chia sẻ về có bộ xong học bên phát triển không? Không thấy bộ. Có vào không? Dạ, có động lực ngay. Luôn lại. Có bộ giỏi ha. Hai trang bị đến hai cái kim ngon luôn ghê. Đó là cái thứ cấp 3 này. Hiểu không? Khải. Đây Khải không? Đây Khải hả? Cái gì quên rồi? Khoa. Em không bác? Chưa hiểu nữa kìa. Tán đâu tán, tỉnh táo rồi không hiểu rồi. Chỗ nào không hiểu bác thầy này chỗ nào?
Nó công thức lacking là EA sẽ trừ cho nguyên cục đó thì nó ra được này còn xong.
Ừ.
Còn
Trừ thì chỉ qua cộng đó, có sai gì đâu. Đó.
thì cái là vi phay nó bị trừ lại tại để đi nó ngược lại.
Đó. Có một bạn là bị rối nè, đúng không? Bị rối. Hiểu rồi. Tức là gì em muốn cái này thành dấu trừ đó hả?
Vâng.
Là motor.
Mình sẽ có hai cách. Một cách là mình sẽ thay đổi gốc ở đây, hiểu không ạ? Hai là mình thay đổi đây dấu trừ, giữ gốc lại là trừ theta giống như kia. Nhưng mà là thay vì nó làm như thế thì mình rất khó hiểu, thì mình chỉ nhớ một công thức thôi. Và cái mình thay đổi là mình thay đổi cái gốc, hiểu không? Đấy. Thì thay vì nếu như mà cái vi phay này luôn luôn là không độ rồi, thì chỗ này thì nếu mà chúng ta tính ra được là gì? Trừ theta. Ở trên đây là ai ấy với góc là cộng theta, còn chả cần quan tâm đến cộng trừ các bạn nữa. Còn đôi khi thì tùy, tại sao tùy? Tại vì nếu như bây giờ em dùng cái góc trừ này nó còn phải xét thêm cái RA nữa. Đó, ví dụ RA cộng với J của SS ham IA nè. Đó. Thì nếu mà nó là leading thì 2 cộng thành trừ, đúng không? Cũng được luôn. Thì tùy, hiểu không? Tùy. Thì thay vì như vậy thì thầy sẽ thay đổi cái lúc. Nhưng mà có AI thì nó rất là cẩn thận nha. Mình phải tách nó ra nha. Mình phải tách nó ra là gì? Phải tách nó ra là IA. Cái này luôn luôn cộng nè. Chỗ này chỉ thay đổi cái trừ đây nè. Thì cái góc này giữ nguyên. Nhưng mà làm gì chứ nó phức tạp. Đúng không? Mình chỉ nhớ là gì? Mình chỉ nhớ bấm vào vấn đề là nếu nó là login thì nó là trừ filter còn trên đây cộng filter. Chả còn mà chỉ nhớ công thức là gì? Cái này một công thức duy nhất là xong. Okay, so that's question C. That's question C. What's the efficiency of this generator? That means we need to calculate input power and output power. Yeah, because they require us to calculate efficiency, so efficiency is output over input power. Okay, so for output power very easy because this one is generator, so output power is electrical power, or this one is 3-phase. Okay, so it's up to you. If we use 3, here is 3-phase IA cosine theta. Cosine theta. V-phase how many? Lagging, you know, lagging. So V-phase is 277. IA how many? 60. Right? Cosine of what? Cosine of 37, or this one is 0.8. Right? Yeah. And you get how many, please? You get, and here this is explanation for you, you know. Yeah. Because I am afraid of you don't understand this one, so I just demonstrate here. Yeah. More understand. So now you get how many? 34.1 kilowatt. Yeah. So we need to calculate B in, so B in is B out plus delta B total. And we know delta B total is what? A delta B correction and width plus delta B straight plus delta B core, right? Plus delta B RCL plus delta B SCL, right? RCL means rotor copper loss. SCL means stator copper loss. Okay, now we don't have delta B SCL because I is 0. Because I is 0, right? Yeah. And we don't have any information about field winding, field circuit. We don't have. So that means this one is 0. Okay, so we have here. We don't have the information of stray losses. Okay, so we have version of witness and delta B core. That means you get 1.0 plus 1.5, you get 2.5 kilowatt. And then you can get B in this E 34.1 plus 2.5, so you get 36.6 kilowatts. Yeah, so you can get efficiency, and efficiency will be 93.2%. D how much sharp torque must be applied by the right mover at full load. How large is the induced counter torque? That means they require us to calculate applied torque and induced torque. Right? Yeah. So we know applied torque is B in over omega m, right? We have the formula. So B in now is 36.6 kilowatt. Omega m how many? We calculated before. 104.7. Remember this is kilowatt. So how many degrees? That this is the phasor diagram I also draw here. I haven't tried it, but you can draw for yourself because you have more information. Later on, I will draw the phasor diagram. So we have the applied torque is 349.6 Newton meters, and we also get induced torque. Induced torque is what? A B converts over omega m. Do you know B convert? Yes. So B converts A 3 E A, right? I A, right? What else? Cosine. Cosine what? Cosine Rammer. Cosine Rammer. Okay. Cosine Rammer. But we don't know Rammer because we don't know the phase angle of A8. Right? We don't know A8. We don't know. So come back here. Come back to Lakin here. You can calculate the phase of the Rammer, right? Right? So now, come back. Come back. We have EA is what? EA is V phase plus, but now we have V phase E, how many? 237 with 0 degree, right? Plus J, XS is 1, right? IA how many? 60 with, because this is lucky. This is lucky. This is lucky. Where is lucky? Yeah, it's lucky. Just lucky, okay? Lucky. Am I right? Yeah, lucky. So you get minus 37 degree. Okay, so now please help me. How many EA and phase angles? Phase angles. And of course, AI will be 277. 277. Oh, this is not. Yeah, right? 277. Okay? Okay? Something wrong?
Your power calculation.
Yeah, something wrong here. We face this is not. I mean the PE. PE. You know, PE. This one is not 277. But this is lucky, right? Lucky. So we face how many? We face how many? 237. Oh my God. Okay. Yeah, please remind me if I have something wrong. Now, double check. This is 21.24 watt. Yes. Okay. Okay. Correct. Yeah. Yeah. Remind me. Yeah. Otherwise, yeah. You know, I have two sides of sometimes I make mistake. So here you get what? Here you get. Of course, this one is 277, but I don't know. Face angle. Please calculate.
Tính là tính cái góc này là
Come on, quickly. Cái ngón này lâu trời đấy. Nine point 95. Okay. So now we know here is 9.95. Okay. So you get 3 times. EA how many? 277. EA how many? 60. 9.95. How many? Sorry, how many? How many? Cosine of this one is what? This is Rammer, right? So we have IA is how many? IA is IA with minus 37 degree, and now we have EA with how many? 9.97. So here 95, 97. 95. So here you should plus what? 37. Yeah, how many? Why we have here? Because for lucky, you know, this is V5, right? And this one is IA. This angle is 37. Okay, so this is IA, RA. So this one is J's XS IA. Then this one is EA, right? This is delta. This is theta. So this one is Rammer. Okay, so how many please? One.
Now
34 kilowatt. Okay, so now this is 34 kilowatt divided by 104.7. Yes, and we can get the answers. So here, you get 271.1, no, 271.3 Newton meter. Okay? Yes. So why, or we have another way. So if you remember the power flow diagram, so if you remember the power flow diagram for generators like this, right? This is B in, that means mechanical powers, and this is B out, mean electrical power. Is that right? Yeah. So we have what? We have delta B friction and windage, delta B strain, and delta B core, right? And this one is delta B SCL, and this one is B convert, right? And delta BCL is 0, so based on the power flow diagram, we can conclude directly B converse is approximately equal to B's electrical. And B electrical how many? 34 4.1 kilowatt. That is the reason we have 4.1 here, because we assume that's being converted nearly P out. We skip what? We skip delta B SCM. Okay? Do you understand? Otherwise, we need to calculate how many EA. You know, so the phase angle of how many EA and the phase angle of EA. So now when we know the magnitude of B phase, we come back, we can get the phase angle of EA, and then you draw the phase diagram. You draw the phase diagram. You can determine REM. If you know REM, you can calculate converted power. Do you understand? If you don't understand, ask me. I explain to you again. Yeah. How about you? But questions? Okay, so yeah, this one for this very easy, you know. We calculate the voltage relation. Remember, just remember the formula. We have the difference between no loss and full loss voltage divided by full loss voltage, and then you get voltage relation for lagging case, unity case, leading case. Okay? Oh, còn nữa hả? Nhiều vậy? Nhiều ví dụ vậy? Just a break. 10 minutes. Hiểu không? Thầy giảng hiểu bài không? Nó bị sai chỗ này không mà phải 125,7 đâu, trên đó phải là 104,7. Cái này để textbook nó bị sai. Chia lại cho thầy cái số này phải ra đéo ra mấy 325 chấm mấy 325.69. Chỗ này nó bị sai ha, chỗ này cái textbook nó bị nhầm thôi. Sửa lại bị nhầm ha, bị sai. Textbook bị sai ha, sửa lại ha, chúng ta phải ra lại như 325.69 ha, sửa lại ha, sửa lại. Textbook chỗ này nó bị sai ha, nhớ ra tính lại. Để thầy sửa đây luôn, bao nhiêu 300 mấy? 325,7 rồi đó.
Tại vì cái bài này nếu mà mấy đứa này đã không biết được nghe bằng cái cụm não rồi để người ta không mà không, ví dụ như con này mày có cái não mà cái não được đấy mình có hay mà câu đó mày có cái não mà cái dây một khu dưới là mày tính không có nào vui không sao không mà không thích mày không biết tính không được biết bỏ thẳng mới tính được vậy có một tiền gì GPT nó kêu nó vào không
con là con ấy.
chưa ăn gì đây cái bài này được hỏi câu hỏi câu hỏi thì nó phải vậy cái bài này nó đã cho mình cái không trả lời bài này không phải đâu có xấu còn cái bài thì dính luôn hay mà họ đất rồi
Mày thích mua nước
họ cho làm lại họ cho mình
tao tính kêu mày ôi cho tao
và họ có thể
số đầu nặng
chưa thì sẽ một hai kỳ đó con nào đâu tự ta làm thì bây giờ nó đi lâu đấy vì cái này
cái này là nhạc
ít tiếng mắt cao ít mắt không chịu nghe
nhưng mà bạn là 9 năm
theo biết số nữa đường thành đường nó mới chọn các bạn còn phải bên này hết không là super chắc chắn nghe chứ nó là xấu tại cho cái loại tôi là trong review cái này phải lấy gì không giỏi này thì lấy gì được thì Trời ơi, không lúc nào được luôn á. Hai cái học lý trái từ đời thì không cần mỏi này nó có thể tại kéo một tuần không luôn cái này sẽ tự vô lại thành hai ba học hai là cuối cùng giờ bấm một hai
đầu thay vì mình hỏi đầu một mình hỏi từ gốc luôn, nó muốn phải chồng với
cái này vậy chứ thầy hai bài phải cái gì đó chứ thầy không lừa khác hay gì tại vì là cái gì gọi là
last hope.
kêu mình đâu chịu ra chỉ để sống mình không yếu gì chung một ba nổ quá nhỏ đỏ ô biết vậy rồi rồi không gọi là phi cơ một cái mũi
Ủa anh tự đi hoa bài của mình.
hai bài hai bài để hỏi cái gì cũng được à dễ ví dụ đi giờ để là tất cả đều là đi xuống chuyện đi xuống vậy là chị đi 1.1 rồi thì ví dụ mua về thôi thì cái này thằng cũng xong rồi là đi là chị đúng đường luôn chị thấy đúng ô center cái đọc của ô sang đọc giờ nó đi cái này đọc ta tự uống xong thì nhiều điểm hết của uống tới là phía ngoài giờ thấy chiều nó đi nữa đi xuống là chia nhau đó thì cái này là cục nào UV W thì từ UV nó sẽ là cộng U thì để mình đánh giá gì cho mình đánh giá khó chịu gì thì là vậy luôn tôi nhớ đi trong cái này nhám luôn cái nhà hàng nào này chứ tám giác ba nhà
Để khoái nhớ lại gì không quay?
Cái đồng ý thì cái này đúng để nó đi ngồi và cái tên này để đi từ U sang đây cái là một U chỉ này U đây là U thì sẽ một U thì cái U bên này chỉ là cái tên ở này chỉ là đúng được thì ví dụ này từ U sang V cũng là U sang đây thì đi được không? Được không? Mình nhớ là gì để lại thì đủ cho càng ngày bắt đầu này kiến thức để như này đi qua đây là tới đây là chụp cái của nó đâu có bắn thẳng này không có một đường không có đường nào dài không một đường cái đường nó đi cái đường cái này là cái khoảng trống không phải là không cái dấu chấm là cái dấu nối nếu như không có dấu chấm là không nối nữa rồi nếu như đi vào đây không đi dưới này bạn không có đi dưới đây không nữa đi cái đường có tay cái để có tay đây đó là cái đường thẳng đi ông có một đường đúng rồi thì nhớ là cái chiều đi xuống đúng không thì cái này nó đi qua đây nha còn ngoài cái đây nó không đi xuống đúng không nó đi vòng lên đây nó đi lên nó này đi xuống đúng không cái này cục này là gì cục này cổ nào cổ cộng với chữ đúng rồi xong qua tới bên này cục này là số 2 cộng với chữ tới qua đây cục này có này xuống đây cục này có đúng rồi cái số được không cái số là chỉ là cái hạng nào cái này hạng nhất còn này hạng hai là cái bao nhiêu cái này là một cái này cũng là ô này đây cái số này số chỉ là mấy không phải là bao nhiêu thì cái này là một ô này ô một cái bằng còn này ô của đây là một ô dưới đây là một ô còn đây là của UV đây là trừ U cộng V trừ W cộng V và bãi này luôn và trừ U đi xuống này là đi xuống luôn U lên lên đây là trừ U đi xuống và sao này là đi xuống này đi xuống này đây về đi xuống đây thì giờ hai một cây về ôm một về đi lên khu hai về nó sẽ hướng xuống nói chung cái hành về có này đi về kia 30 luôn không muốn luôn cái này là gì đây là D thành là 4 6 vậy đó nó không khó gì đâu nó chỉ có nhìn cái đường nó đi cái đường nó không đi lên hết rồi vậy đó bởi vì nhưng mà thấy làm được thì chọn nào cái chế này làm lại từ đâu đến đâu để ra đi đâu từ U đến đâu U đến đây đi rồi nó đi cái này đi qua cục nào cục đây chỉ là mua về là chỉ đúng rồi đọc U2 UV đi như nào đọc
So now we have example 4. Okay. So I think you should read carefully the question first. So, sim generator is example 3 is operated at no loss. Okay, with terminal voltage 490 volt. Okay, plot the terminal characteristics. I mean terminal voltage. Okay, line voltage and line current of the generator. Okay, for two cases. 0.8 lagging and 0.8 leading. Okay. Yeah. So remember that this is the phasor diagram for lagging loss condition. This is we phase This is IA. Okay, IA. Yeah. And we have the phase angle here is 26 point, but A that means 37. We have EAE 277. Okay, because no load line voltage is 480 volt. So we divide this by square root of 3. We can guess phase voltage magnitude is 277. And delta here, how many? Delta here, how many? Yeah, we calculated before, right? Yeah. We get how many? 9.95, right? Yeah. So we get RAM is nearly 47 degrees. Okay? Yeah. Yes. Here we skip RA. Now I also consider I, but that's okay, we can skip I. So we can use MATLAB. Can you install MATLAB? So remember that, okay, you need to install MATLAB. MATLAB, at least 2024, at least. But now we have 2024B, 2025A, okay? But I think 2024 is very good. Okay, yeah, I if you believe your laptop performance is very good, you install 2025A. Okay, otherwise it's that's okay. Yeah. And then this is light current terminal voltage for power factor lagging. This one is light current and terminal voltage for power factor leading. Okay. So when we increase light current, that means we reduce terminal voltage. Look. Here, when we increase IA, right? That means we reduce phase for lagging. For leading, reverse. When we increase IA, we decrease, we also increase terminal voltage. The reason is why, okay, because we have for leading, we phase is EA, okay, yeah, EA, minus JXSIA, but IA here is positive, okay, positive. Leading. Or we can say EA plus JXSIA. This is minus. Okay. So when we increase the magnitude of IA, that means we increase phase. Okay. Yeah. So we have the first way, we just keep it minus, but this is plus. Right? Yeah, this is leading, or if here you also keep minus, this is plus. Okay, so maybe we skip this one, because this one is positive. Okay, so when we increase IA, we also increase phase. Like this, like this, like this, like this. Phase is minus, JXSIA, this is positive, okay? So if you move to the left side, you get phase plus JXSIA is positive. And then, after that, you can see, phase A 309. And AA is only 277, right? AA only, where? Here, AA is also 277. So when we increase light current for power lagging, power leading, terminal voltage is increased. Okay? You understand? Yes. And this is the phasor diagram for lagging. You know, when we increase light current, we increase terminal voltage. Homework. We have program 1, 2, 3, only 3. 1, 2, 3. Okay, finish. Lecture 2, part 1. Now we go to lecture 2, part 2. We go to 2.9. We discuss about parallel operation of AC generators. That means we have many generators are connected in parallel. Okay. So before we have one generator, one lot. We have many generators and many lots. Okay. So, read this slide first. You know, this slide answers the question, why are synchronous generators operating in parallel? Okay, so that means we have one bus. So we have many generators, synchronous generator G1, okay, G2, blah, blah, blah. We have Gn, and we have many lots. This is lot. Yeah, lots. So, look, there are many advantages. Several generators can supply a bigger lot than one machine by itself. For example, here we have B1 plus JQ1. This is active power and reactive power from generator 1. This is B2 plus JQ2, blah, blah, blah. We have Bn plus JQ, and of course, the power here is three-phase power. So we have total power is V1 plus V2 plus blah 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 plus Vn, right? Okay, plus J Q1 blah 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 plus Qn. That's QA. So we can increase the reliability. Why? Because sometimes if G1 is broken, we have the other generator to keep continuing to supply the load. Okay, to send the power to the load. Okay, so more reliability and so on. Okay. So here, how many generators? We have two generators, 1, 2, and this is load. Okay. So first of all, only generator 1 connects to the load, right? So after some time, we would like to connect generator 2 into this system. Okay? So we cannot turn on circuit breaker here anytime we want. No. Okay? So before we connect generator 2 to the system, we need to satisfy some condition. This is the rule when we connect any generators into the system. Okay? Yeah. Now, how many requirements we need? 1, 2, 3, 4. 1, 2, 3, 4. So, the first one we should have. So if the generator 2 would like to connect to the systems, you should make sure the RMS voltage of generator 1 and generator 2 must be equal. That means we have the same RMS voltage. For example, this is generator 1 and this one is load. It is 3-phase. It is 3-phase, so we have VA1. VA1 means phase A voltage of generator 1. We have VA, VB, VB1. And this one is VC1. Okay, so we have generator 2. Yes, we would like to connect to the system. This is circuit breaker. This is 3-phase. Okay, so for generator 2, we should make sure RMS, or also for, or sometimes we say the magnitude, but that's okay. That means VA1 should be equal to VA2 and so on. So here must be VA2. Here must be VB2. Here must be VC2. They have the same magnitude or the same RMS value. So if we have the same, that means we don't have the different voltage between VA1 and VA2, right? Because this one equal to 0, right? Yeah, you can connect. So if delta V different from 0, broke lock, you know. So if delta V is 0, when we close the circuit, we have more active. Because if delta V is 0, is different from 0, we have the current. And when we close the circuit breaker, boom, yeah, circuit breaker rocket. Also, generator 2 will be damaged sometimes. Okay, so delta V. Here I just mentioned magnitude. So number two. The two generators must have the same phase sequence. This is the same phase sequence. This is A, B, C. The same phase sequence. If different phase sequence, what will happen? So we assume this one is VA1, okay, and VA2 get the same. But this one, this is VB1, okay, and this is VC2. This is VC1 and this one is VB2. Yes, problem. Why? Because when we connect, actually A to A, B to B, C to C, delta V is 0. Now, if here is B1 and B2 here, so now when we close the circuit, this is delta V. Delta VB. That's right. Do you agree with me? Because we have different sequence. A and A the same, okay, delta VA is 0. But now delta VB1, delta VB2, so delta VB is very large. More delta VB, more current, boom, the system is blacked out. Okay, so we should make sure we have the same sequence. AA, BB, CC. For instance, number 3. The phase angle of the two A phase must be equal. That means the same phase angle. The same phase angle for every phase. What does this mean? So here we have VA1. Here we have VB1. Here is VC1. You know, one phase is different from each other, 120 degrees. Do you agree with me? So now we have VA1 maybe here, and now VA2 maybe, VB2 maybe here, and now VC2 is here. Problem, right? Because when we close the circuit, we have delta V also. Delta VB. Right? Because different phase angle. Even though we have the same magnitude, but different phase angle. Natural. Because we have delta V. And then we cannot connect generator 2 into the system. Is it clear? And the last one, we should have the same one. The same frequencies. Okay? So if this one is 50 Hz, this one must be 50 Hz also, the same frequency. Because different frequency will also appear. Problem, you know, should make sure the same frequency. That means F1 equal to F2. Okay, so if all requirements here are satisfied, we can connect generator 2 into the system. Okay, and this process is synchronization process. We say this one is synchronization. Synchronization of T2 into the system. Okay. Vietnamese synchronization means hòa đồng bộ. Đồng bộ nghĩa là gì? Đồng bộ điện áp, đồng bộ thứ tự pha, đồng bộ gốc và đồng bộ tần số. Okay. And if we come to the lab, we have one lesson, okay, to practice the synchronization process. And Mr. Hiếu will guide you how to synchronize the generators into the system. Okay? Yeah. So, how can we know we satisfy all requirements here? Okay, how can we know? Now, this one just to let you know, to synchronize the generator into the system, We need to measure the same magnitude, phase angle, sequence, and frequency. Okay, you can operate many generators in parallel. Okay, so if we have the questions, if we have V3, we also follow the same, you know, step by step. First of all, we synchronize or we connect T2 to the system. When you finish, you continue to connect T3, T4, T5. Every step, only one generator connect to the system. Okay, generator by generator. Okay, we cannot close many generators to the system at the same time. No, very, very difficult. Don't do that. Okay? Yes. So, so this is the way. This is the way. This is the way to check on requirement here. Okay. Yeah. So the easiest way is to use the light bulb. The light bulbs. How many light bulbs we need? 1, 2, 3. Okay. So now you have. I think you have. I think you have. Yeah, 3 minutes. Ready? Okay. How can we get the synchronization process by using 3 light bulbs? Okay, come on. 3 minutes. Ready? So if we would like to control the frequencies, we need to control what? We need to control the speed of the rotor. And that's right, because we have N series 60F over whole pairs. So that means FE, B, and C over 60. The number of whole pairs is constant. 60 constant. So when we increase synchronous speed, we increase frequency. Right? We reduce NCN, we reduce frequency. Okay, so if you double check and you recognize F2 is different from 15, increase the speed of the rotor. Otherwise, reduce the speed of the rotor. Okay? How can we control? Control what? Control voltage, IMS voltage. That means we control what? We control V phase. We control V phase. Or we control V terminal, right? How can we control the terminal voltage? We have the formula, right? We have EA is V phase plus J plus what? Plus RA plus JXS times IA overhead. IA over dot. Okay? So if we would, so that means we have V phase is EA minus RA plus JXS IA. You know? If we would like to control, to increase V phase, we need to increase EA. And we know EA is like proportional to what? K phi m omega. Right? So, if we would like to increase EA, we increase phi m. What does this mean, phi m? Rotor magnetic flux. So, when we increase phi m, that means we should increase field current. the current flowing into the rotor winding, right? So to control V phase, that means we control IF. To control frequencies, we control speed. You know, every time you must control one parameter, not both of them. You know, when we control the frequency, keep IF constant. When we control the terminal voltage, you need to keep the speed to be constant. Control IF. You know, every time control only one parameters. Okay, is it clear? Yeah, and then you can make sure we satisfy all four requirements. Okay, so the easiest way we use 3 light bulbs. Okay, yeah, of course, you read this one for yourself. I just give you the conclusion. When the 3 light bulbs on go out, that means light off, right? The voltage difference across them is 0, and then the system are in phase. Okay? So if we use 3, we use the easiest way. We use what? We use 3 voltmeters. And we use, we use voltmeters, not 3 many. And we use 3 light bulbs. Okay? Yes, yeah. So if you don't want to use voltmeters, you can use 3 light, and if all of them light off, okay, you immediately close the circuit breakers. Okay, to get the synchronization. You know, the time when the 3 light bulbs on go out very fast. Okay, so you need to use you need to be concentrated. Okay, you use your eyes and observe. If 3 light bulbs turn off, immediately close the circuit breakers. Okay, so if you come to the left, okay, you need to do that. Okay, you observe 3 light bulbs, you know, and then, you know, you use your hand very quickly. If all of them turn off, close circuit breakers. Okay. Why? All of them turn off, we can close because delta V is 0. Okay? Yeah, definitely 0. Definitely 0. Yeah, and then half of frequency, we should have the same frequency. You know. If all 3 bulbs get bright or dark together, then the system has the same phase sequence. Okay, the same phase sequence. Okay, so we can use voltmeter to double check delta V. Okay. But of course, this one is the easiest way, but stupid way, because we cannot believe 100% of operators. No, you know, sometimes you get drunk, drink some beer and get drunk, and you observe the synchronization process, very dangerous. You know, you cannot believe from our eyes, you know. Yeah. So we think about, we use another method. This one we say synchroscope. Now we don't want to use 3 light bulbs, we use synchronous. Okay, synchronous. For this one maybe better than the ribbon. Now 5 minutes, ready? How can we use synchronous? So if we use synchronous, you can make sure we have the same frequency between G1 and G2. Okay, here, if F1 higher than F2 higher than F1, that means you get fast frequencies. Otherwise, if F2 less than F1, you get slow frequencies. Okay, so here, here, when we operate generator 2, okay, you observe these the fluctuation of this speedometer. Okay, right? This is the speedometer. Okay. So, so if this pointer is at the middle position, that means we have the same frequency between F1 and F2. Okay. Yeah. And then this one just frequency. How about the voltage, right? So we use voltmeters. So the second way we use voltmeters plus synchronous. So this one to measure what? To measure the voltage. Okay, the voltage. To measure what? To measure delta V. And this one to measure the frequencies. Okay, so if the needle is at the middle and the same voltage between Q1 and Q2 cross the circuit. Okay? Yeah. Now, the modern way. So now we have some microcontrollers. They will help us to double check for requirement here automatically. Okay? And they close the circuit automatically. We don't need to use our eyes, and we don't need to use synchronous. Okay? Everything is automatic systems. Okay? But in the lab, we use this one and this one. But in this is automatic device. Okay, they will automatically check the same frequency, the same voltage, the same magnitude, the same sequence. For each cell, we just observe and make sure the operation of the device is operated very well. Okay? Yeah, this one I discussed before. Okay? Yeah. We also understand the speed deviation. Yeah. SD, or which is speed slope. Okay. So we define the speed drop is no loss speed minus full loss speed over full loss speed. Okay. Yeah. Normally you get 2 to 4%. Okay. You know, every synchronous generators we have S. S is parent power, and S three-phase is V three-phase plus J three-phase. And every serial generators we need to consider V terminal. This is line voltage terminal line voltage or V phase or V phase. Okay, and the phase angle of V phase or VT. Yeah. So that means we have V, Q, V, F, theta, right? Maybe it's phase angle, I say phi V, okay, and F frequencies. F, right? So if you come back to the lecture 2 part 1, every question, they also give this information, right? How frequencies, rated voltage, okay, and how many S we have. Yeah. And we have the relationship, So when we control B, you need to control F, or you need to control voltage, right? So when we control Q, we also control F and control V. But for simplicity, the relationship between Q and F is very weak. Okay, so for undergraduate, we skip this relationship. And the relationship between V and V is very small. So just skip it. So we have the good relationship now. If you would like to control V, you control F. We control V, that means we control Q. Okay. So if you would like to know details, why we have this relationship, you study master program. For master program, we need to analyze why we have the relationship between V, F, and Q. But for undergraduates, okay, you just get two relationships, Q, V, F, Q, V. Or we say Q, V curve and V, F curve. So V, Q, V. Why we have this good relation? Because everybody know 3 V phase IA and cosine theta, right? Yeah. So when we increase F, that means we increase ansins. We increase ansins, that means we increase omega. Right? We increase omega, that means we increase EA. Because we have EA proportional to K phi M omega. We assume phi M is constant, so when we increase it, that means we increase EA. Right? We increase EA, that means we increase V phase. Will you read with me? Look, when we increase EA, that means we increase V phase. We increase V phase, that means we increase 3 phase. Are you with me? Be there. Okay? Yeah. Okay. So, Here also V. Here also V. But you know, for B, when we increase a little bit F, that means we increase more B. More B. Of course, when we increase V5, we also increase B. We also increase B. Yes. But we should increase larger and larger V5 to get BQ. Okay. We don't want to increase V5 because it depends on the construction or materials of the winding. So if we increase more V phase, okay, the generators will be burned out. Okay. So that is the reason the relationship between B and V is weak. Okay, and similarly we have QV curve. You understand? So we assume this one is linear relationship. Linear relationship. So we have the diagram here. Look, speed versus power and frequencies. Okay. Okay. Oh, this one just for about until power. Later on we have V. This one is speed and frequency the same, you know, because when we increase speed, we also increase the frequency. Okay, so here the x-axis or horizontal axis is power, output power of generator, and here this is the frequency. You know, if the power is 0, that means no loss condition, right? So no loss of the frequency, you see F and L, that means no loss frequency. So if we have loss, we have power. So when we increase power, we decrease F, no loss, to become F, full loss. Okay? Full loss means rated, so this is rated frequency, this is rated power. If you don't want to use frequency, you can use the speed, the same, you know. Okay? Next. Relationship. What is this? This is linear relationship. So this one like this slope. So this slope is constant, right? Because this is linear. This slope will be constant. Okay? Yeah. So we formulate this diagram to the formula. Okay? So the formula. dF. So here we have F, we have B, right? This is no loss. This is full loss. No loss, full loss. So here this is rated void. Rated void. Yeah, so this is B rated. Okay, so you get this curve, right? Yeah, so we have B with A, S, B, that means slope, times F, no loss, minus F, full loss. Right? Or if we consider this is point A, this is point B, this one is B, and F full loss. This one is 0 and F no loss. Yeah, everybody knows this one we can calculate slope, right? This one minus 0. Okay, anyway. Okay, so here we can get X is A, B over no loss minus full loss. Or you get the formula here. Okay. You understand? Yeah. So this is megawatt. Normally the units of electric power is megawatt. Or you can use kilowatt, gigawatt, blah blah. But normally we use megawatt. How about the frequency? Hertz minus hertz. So the unit is hertz, right? So the unit of this slope is megawatt over hertz or kilowatt over hertz. You understand? Yes? And similarly, we have QV. Q V QV. Yeah, and we also get the formulas. We also get the formula. Q is SQ, V no lot, V terminal for no lot, minus the V terminal for lot. Remember, terminal voltage is always line voltage. Okay? Now, the last questions for you. Question. Look. When we consider BF, we only focus on the first part. Right? Right? That means B is always positive. Yes, definitely. The question is why? If we consider QV, we consider two parts, the first part and the second part. Why? Why? Yeah, why? I don't know. Yeah, you should know, of course. If you don't know, you fail this course. Because if you go to the lab, we have the lab session like this. Sometimes we get positive Q, sometimes we get negative. Okay? Negative. So here, look. If I say this is lot, okay, this one is generator. That means we have BG plus JQG. This one for lot. We need what? BL plus JQL. Okay? Look. We need BL, we need QL. So lot mean R and L, XL. Do you read? So if we need BL, we need QL, you need positive BG, positive BQ, because if the system is balanced, that means BG is BL and what else? And QG is QL. Yes, definitely. Now, I have capacity lot. So if we have capacity lot, do we need QL? No, because capacitors to generate reactive power for itself. We don't need Q here. Q here. You know? So if here we have resistance and capacitor, so here is minus. Right? Because capacitor will generate reactive power. So if here is minus, and then if we continue to generate QR, so the total Q is QR plus QL. Boom! System is blackout. You know? So if here we have capacitor, here should be minus. You know? So if here it generates reactive power, the generators will consume reactive power. You get minus. Okay? But shouldn't do that. Shouldn't do that. Why? Because if the synchronous generator consumes Q, that means more thermal, more temperatures. Boom! Synchronous generator will be damaged. Okay? So you should make sure we generate VGs and JQG, or, you know, for the ideal case, QG is 0. We hope. We hope. Okay? Yeah, so if we have inductive loss, of course we generate V, we generate Q, and we consider the first part. So if there is capacity loss, this one now generate what? Generate V, but consume Q. Okay? So this one like lacking loss. This one like capacitive loss or leading loss, you know? But don't worry, for the last session we have inductive loss. Okay? So, stop. See you afternoon. Okay?